and do these. So I've got two homework problems I'm going to do. These are just from my math lab. Here is the first one that we've got. So we're given this, this half circle looking thing, and we want to know what the shaded area is. So I'm just going to transcribe this to my sheet of paper so I have it to work with. So I've got an outer edge and I've got an inner edge. And I want to figure out what this is right here. I'm told the dimension of the smaller part is 7.5 inches. And then the outer part is 15 inches. Okay, great. All right, so I'm going to stop sharing the screen. And now here we are. All right, so this is my fantastic artwork representation of what you just saw on the screen. So we need to figure out that shaded area. So first off, I know it's just half of one, but what are these figures based on? They're both what? The outer and the inner are both what? Yeah, they're both circles. They're half of a circle. Okay, so what I'm going to do, if you'll allow me, is I'm going to pretend that I have a full circle that I'm doing this for, and at the end, I'm just going to take half of the answer. Okay, does that make sense? Yeah. So I'm just going to pretend that I've got big full circle here, and then at the end, we'll just take half the answer. Okay, so what we're going to do first is we're going to find the area. I'm just going to put the word big here. I'm going to find the area of the big circle. Well, again, since you've stayed and you want to review, what's the area of a circle? It's pi times the radius squared. So the big circle is pi times 7.5 inches squared. So I throw that into the calculator. I'm doing the bigger circle. So the bigger circle is a 15-inch. That's great. Yeah, these measurements are very similar. The bigger circle is 15 inches across. So half of that is 7.5. Okay, we'll get to the smaller one. That's why I put this little word big here, so we remember that we're doing the big circle this first time. So again, great. I love when you guys ask for clarity. It makes my job easier. 7.5 squared times pi is equal to 176.71 inches squared. You with me so far? We're doing all right? Now remember, that's the full circle. Okay, I haven't done the half yet. We'll do that at the very end. Then the area of the small one is pi times r squared. Well, if you need to use your calculator, half of 7.5 is going to be 3.75. So here's my smaller circle. Half of that distance is 3.75. So again, to my calculator. So I have 3.75, which I'm going to square. And then I'm going to multiply that times the pi. And I get 44.18 inches squared. Okay, second to last step. I found the area of the big circle. I found the area of the small circle. What am I going to do with those two areas to get the shaded part? I'm going to subtract them. I've cut a hole in the middle of this circle. So I'm going to take the 176.71. I'm going to subtract 44.18. And so again, that is 176.71 minus 44.18, and we get 132.53. I would be done if I had a full circle, but my last step is to do what with this measurement right there? Yeah, this right here, just in case, I don't, if you're taking notes, this is the full circle. And so the answer, my shaded region, is just going to be 132.53 divided by 2, because it's half circles. So divide by 2, and I get 66.265, so 66.27. Great first problem. You said there was 2, so let me again share the screen here, and we will go to that problem we were just at, and we'll go to the next one. So this will be the second homework problem. So what we've got is a square inside of a square. So we're given some dimensions. So I'm given my outer square, I'm told, is 34 inches at a pop. And then I've got a square inside of it. So I've got 34 inches and 34 inches. And so I'm asked to find the area of that square inside. Okay, so I'm going to definitely do this problem, but this is not my favorite problem because I probably should actually just delete it. But anyway, it assumes a little bit of knowledge that maybe, it assumes you're going to assume something that is not necessarily a given bit of information. But we'll do this because I think once you have that information, so I've got a square inside of a square. So this point right here on the square, just from the way it looks, what do you think we can say about these two lengths right here above where the point of this square intersects this side? Yeah, they're going to be equal, okay, because everything's square. Everything in square land is equal. Okay, so this side right here is going to equal that. So if this full side is 34, then that means each of these bits is going to be what? 17. So this is going to be 17 inches. This is going to be 17 inches. Yes, and what we're going to do is we're going to use the Pythagorean theorem to get the two sides of the square on the inside. Okay, so this is going to be 17. So it's just, that's the assumption that you have to have, that maybe you didn't think you could make because it's not notated on the picture. Other than that, I do like the problem because you have to use the Pythagorean theorem, but I don't necessarily love that you have to make that assumption. So finishing this off then, I'm going to use this. I'm going to figure out, I'm just going to call this x. I need to figure out what the square on the inside is, what its lengths are, and then I'll be ready to finish this problem. So the x squared, we did this earlier. X squared is equal to 17 squared plus 17 squared. And I don't know what 17 squared is off the top of my head. That's 289. So we'll add that to itself and we get 578. And then once again, I've got x squared. To get x, I hit that square root button on my calculator, and that gives me 24.04. So each side of this square on the inside is 24.04 inches. That allows me now to find the area. The area of the square on the inside is just going to be the length times the width. Which is going to be, it's going to round up to 578, that measurement we had before. Does that clear up? Seeing that we can make that assumption that these two things are equal, does that clear up kind of the issue with the problem? All right. Well, great question. I really appreciate it. I love when you bring homework questions.